Well, hello again, ladies and gentlemen. We are going to be looking at final review for number of Unit 2. And if we kind of look at our first different thing, we were going to looking at domain and range and kind of some graphing with this unit. So number 1, parts A, B, C, and D say sketch the graph of our function and state the domain and the range. And if we kind of recall, we had some basic shapes. We had our function y equals x squared, which was our quadratic. We had y equals the square root of x, which is a square root function, kind of looked like a little Nike swoosh. We had y equals the absolute value of x, which looked like a nice little V. And finally, y equals x cubed, which kind of looked like this little squiggle like so. And there's kind of an example of each and every single one of those here. Ultimately, when we were just sketching that graph, what we needed to do was find that starting point. And all of these equations had the same basic principle of y equals x minus h, and then kind of depending upon if it was square root, absolute value squared or cubed, kind of depended upon what goes here, plus k. So that was kind of our general thing going on with each of them. So if we looked at our first one, y equals the opposite of x plus 1 quantity squared minus 2. First thing we have to do is find that starting point. And in this case, our starting point is going to be at -1, -2, because we could solve this little piece right here. So let's go ahead and graph that. And I'm just going to kind of do a rough sketch for all of these. Remember, we can also always look in our calculators. So -1, -2. This tells us our graph is going to be opening downward, like so. And I'm going to label that -1, -2. And now we want to find our domain. And if we recall, our domain is going to go from left to right. So from left to right, our graph goes from -infinity to +infinity. And then range goes from bottom to top. So we're going down here from -infinity, and we are stopping, and this is our highest point, which happens to be -2. So -infinity to -2, and that little -2 is included. If we look at, for example, letter B, this is going to give us a square root function. And with that, y equals the opposite square root of -x minus 4 plus 3. So we still need to find that starting point. This one's a little tricky, so I'm going to go ahead and go -x minus 4 equals 0. -x equals 4. So, x equals -4. So our starting point is at -4, positive 3. I should have brought my whiteout home, is all I can say. So -4, 3, 1, 2, 3, 4, and up 1, 2, 3. Typically, this graph is going to have that general shape, but this is telling us we're going to be reflecting it over the y-axis, and we're going to reflect it over the x-axis. So first of all, it's flipping this way and then going backwards as well. So our little Nike swoosh ends up looking like so. And I'm going to go ahead and label that -4, -3. So for our domain, left to right, we are going to go from -infinity And then I want to know what is the furthest most x value. So left to right, our furthest most x value is -4, and it's included. Bottom to top, we're going from -infinity, and then we are going to go ahead and stop at their uppermost y value, which happens to also be -3. And ultimately, the next two are done the same way. We just need to be very cautious of whatever, if is it absolute value or is it a cubic. So let's kind of moving on. If you wanted to go ahead and do those, you absolutely may. Number 2 says, hey, write the equation of our function of our graph. And as I mentioned on the previous page, our general kind of form is y equals x minus h, depending upon what its shape is, plus k. So looking at this one, we know this is y equals x minus h quantity squared plus k, since it's a quadratic, and all we need to do is figure out what is that point. And that point happens to be 2, -3. And so we can go ahead and just plug that in and say our function y equals x minus 2 quantity squared minus 3. And then we're going to notice, hey, it opens downward. So that is that little reflection across the x-axis that's going to be out front. So kind of looking at our next one, hopefully we realize that's a cubic, and that cubic would be y equals x minus h quantity cubed plus k, and our starting point happens to be right there, and that is 2, 2. So then this is y equals x minus 2 quantity cubed plus 2. And then very last but not least, that's an absolute value. So we have y equals absolute value of x minus h plus k. And we're wanting to know, hey, what is that point? And that is 4, -5. So we end up with y equals the absolute value of x minus 4 minus 5. So not too bad. And then if we remember, some of the other stuff that we did in Unit 2 happens to be with our piecewise functions. And with our piecewise functions, we are basically going to be dividing our graph into 2 separate, maybe 3 separate parts. So we have f of x equals 2x plus 3 if x is greater than or equal to -3. And we would be graphing f of x equals -3x minus 5 if x is less than -3. What I like to do is use this -3 right here as a dividing line. So we're going to go ahead and go back 3. And it's kind of this little invisible dividing line that we're going to have. And so if x is greater than -3, so on this side we're graphing f of x equals 2x plus 3. And then on this half, if x is less than -3, we are graphing f of x equals -3x minus 5. So now we just made a little table. I'm going to go ahead and graph this part first. So f of x equals -3x minus 5. Make a little table of values. We're going to pick -3, and then I want a number less than -3. I'm going to just choose -4 and then plug them in. So what is -3 times -3, so 9, minus 5 That is 4. Gonna go ahead and plug in negative 4. Negative 3 times negative 4 is 12. Minus 5 is 7. So I'm going to go ahead and graph those two. So negative 3 and then 4. This is where we need to be very careful that this point right here is not included. This one right here, because of that less than sign. And then negative 4, and then 7. And then we would then use our straight edge, which I don't happen to have, and then connect those. Remember, this is just kind of that extra point. This is the one we need to decide, is it filled in or not. And then on our second half over here, we're going to graph f of x equals 2x plus 3. Make our little table of values. Choose our negative 3. And then I want a number bigger than negative 3. I like 0. You guys know that. So negative 3 is going to get substituted in. So 2 times negative 3 plus 3 happens to be negative 3. And then 2 times 0 plus 3 is 3. So we're going to go negative 3, negative 3. And this one is a closed circle because that happens to be greater than or equal to. Equal to makes that closed. And then we're going to go 0, 3. Make our extra point. Remember, that's not necessarily filled in or open. It's just kind of a guidance point. And then we're going to go ahead and use our straight edge to graph. So there's our piecewise function. We also were evaluating piecewise functions in this unit. So kind of looking, we're given our function, and then we're wanting to find f of negative 1. If we remember, this does not go into all three parts. F of negative 1 simply means where is negative 1? Is it going to be in less than negative 2? Is it between negative 2 and 0? Or is it greater than or equal to 0? So we're going to find f of negative 1 happens to fall in that range. So then what we're going to do, f of negative 1, so we're going to go negative 1 plus 5 is 4. If we looked at the next one, f of negative 3, that negative 3, is that going to be less than or equal to negative 2? Is that going to be between negative 2 and 0? Or is that going to be greater than or equal to 0? We're going to find that this negative 3 falls in that range. So we're going to go 2 times negative 3 minus 1. So that would be negative 6 minus 1, so that is negative 7. And finally, f of 0, where does that happen to fall? It looks like it could go in either one, but notice right here it's not equal to 0, whereas with this one right here, f of 0 is greater than or equal to. So with that one, we do end up with 0 squared plus 3. So that is 0 plus 3. So our answer is 3. So that would kind of be our piecewise functions that we did. The next thing we were looking at in this unit, lots of things kind of jam-packed, we're determine whether each is a function determine whether each equation below defines y as a function of x. And ultimately with this, we're just going to look at the exponent on the y. If it is odd, it is a function. If it is even, it's not a function. So ultimately with this, all we have to do is look at our y's. So looking here, x squared plus y equals 5. Our exponent is odd, so this one is a function. Looking here, our exponent is 1, so it's odd, so that is a function. Looking here, x plus y squared equals 15. We have a y squared, so our exponent is even, so this is not a function. And this one, x minus 5 quantity squared plus y plus 3 quantity squared equals 49. Believe it or not, that exponent here on our y is also going to be just a 2 and it's squared. So this is even, and so it's not a function. If we look at letter D, if we kind of vaguely remember from our Unit 1, that happens to be the equation of a circle, and a circle definitely would not pass the vertical line test. The next thing we were asked to do in this unit happened to be to kind of evaluate different types of functions. I'm not going to do all of these, just kind of set some of them up for you for some of our notation. Looking at like letter A, f of negative 2, that is simply plug that in to function f. So 5 times negative 2 plus 1, and we know that happens to be negative 9. G of 2x plus 1, we are just going to take 2x plus 1, substitute it into function g. So 2x plus 1, quantity squared, plus 4. When we multiply this out, please remember that's 2x plus 1 times 2x plus 1 plus 4. So that would be 4x squared plus 2x plus 2x plus 1 plus 4. So 4x squared plus 2x plus 5. And then one of the next couple I do want to make sure I do, and I guess I did do those. But f of g of x, that is saying we are taking function g, this whole function g, and plugging it in to function f. It really is very similar to kind of this, with the exception of the notation. So this is saying function g goes into function f. So what that ends up being, function g goes into function f, so 5 times x squared plus 4 plus 1. So 5x squared plus 20 plus 1. So that is 5x squared plus 21. The last one I want to make sure I do is letter D, simply because that is saying g of f of 2. So you could go ahead and do your composite function if you would like, or we can just kind of work inside out. This one is saying we're going to do f of 2, and f of 2 is 5 times 2 plus 1, so 10 plus 1, which is 11. And next, we would then do g of 11. And g of 11, so then that would be 11 squared plus 4. 11 squared, 121 plus 4 is 125. So not too bad. And then the last three, I'm going to just get those set up because that's really just looking at notation. So g of h of x is saying we're going to take function g. So we have x squared plus 4, and we're going to add that to function h. So 3x squared minus 2x plus 1, and then just combine our like terms from there. This is the one where we do need to note that our notation is very different from letter C. This one is a composite function, kind of with that open circle. Just the little dot means multiplication. So f times g of x, so that is simply 5x plus 1 times x squared plus 4, and then from there we would just double distribute or FOIL that one out. And then our last one that we would happen to, and if you're curious, you end up with 5x to the third plus x squared plus 20x plus 4. So very different than our composite. And then our last one is also just saying take function h. So that is 3x squared minus 2x plus 1. From that, we're going to subtract function f, which is 5x plus 1. And then with that, don't forget to distribute your negative, and you can go ahead and combine like terms from there. We are on the downhill slide, ladies and gentlemen, almost done. Well, a few more things, I guess I should say. Then we had our inverses. And with our inverses, it's find f inverse of x. And we are told f of x equals negative 2/3 x plus 17. And with this, if we recall, first thing we're going to do is change that to y equals negative 2/3 x plus 17. And then what we're going to do is swap out our x's and our y's. So now we're going to say x equals negative 2/3 y plus 17. And at this step, what we're going to do is solve for y. So we're going to go ahead and subtract 17 to both sides. So x minus 17 equals negative 2/3 y. We can either multiply by the reciprocal, or you can go ahead and just multiply both sides by 3. I'm going to go ahead and multiply by the reciprocal. So that would be negative 3/2. Multiply everything by negative 3/2. And now we're going to go ahead and distribute that. So we have negative 3/2 x plus, I don't know that off the top of my head. So we're going to go negative 17 times negative 3/2. 51/2, so plus 51/2, equals y. That's a good answer, but not the best, because don't forget it says find f inverse. So we want f inverse of x equals negative 3/2 x plus 51 halves. So there we go. And then it says determine whether the graph below is even, odd, or neither. The big part here is that an even function is symmetric to the y-axis, and an odd function symmetric to the origin. And they would be neither if it's neither one is true. So let's look at all of these. So symmetric to the y-axis. So that means if I folded it up over the y-axis, both halves have to match up. So looking here, the only even function that we happen to have is this one. Oops. Because if I folded it up straight along that bright yellow line, both halves happen to match up and we're good to go. Looking at all of these others, that's not the case. So now, symmetric to the origin means if I turned my paper upside down, so symmetric to my origin would be my little green dot, and if I turn my paper upside down, my graph has to look exactly the same. So if I did that, kind of get in your mind what these look like. And if I turn them upside down, the only one that looks exactly the same happens to be this one. Because if I flipped it right side up again, that graph looks the same. So this one happens to be odd, which then makes the other two neither even nor odd. And we did do an algebraic test for that, and if for some reason that shows up on your final, I will be happy to explain that or help you with that. And then our last bit, here we go. We have our functions. Function h of x, and then we want to sketch what happens when the given transformation is placed upon it. So for example, we want to know what does g of x look like if it's h of x minus 2. So if we recall, this means that we are going to go down 2 units. So we're going to take each of these points and go down 2. Down 2, down 2, down 2, and down 2. Selected. Here, I'm going to go up 1, 2, 3. So now I have 1, 2, 3. That point is now reflected. This one, 1, 2, 3. So 1, 2, 3. And then this point stays the same. So there is our reflection. And then our very last one happens to be r of x equals h of x plus 3. And this is saying, hey, I am going to the left 3 units. So we're going to take each of our points and shift it to the left 3. So 3. And finally 1, 2, 3. And like so. And there we go, ladies and gentlemen. That is Unit 2 in a nutshell. Thank you for paying attention. I know this did take a little bit longer. Have a great day. Goodbye.